Okay, we continue with the week 3 programmable logic controller PLC. Yes. Okay.
The purpose of this module is to introduce the concept of programmable logic controllers or PLCs that coordinate the real-time control functions in manufacturing operations. At the end of this module, you will be able to describe manufacturing as a process, state how automated process control benefits manufacturing, and list 4 components of a programmable logic controller or PLC system. This lesson will provide a basic introduction to process control. Let's start with understanding what is a process. A process is a series of tasks that take certain inputs and generates intended output. For example, manufacturing process is a process that takes inputs such as operators, equipment, and material and generate manufactured product as an output. In order to understand an important term, compliance, related to the process, let us consider an illustrative example of cruise control of a car. You use the cruise control mode in your car to set it to a speed so that you stay within the legal speed limit for a given road condition. Suddenly, the road conditions change, for example, due to ongoing construction in a segment of the road, due to which the legal speed limit reduces. What was legal speed before road conditions change ceases to be legal now. In this setting, driver goes from compliant mode to non-compliant mode because of the changes in input, that is, the road conditions. Output of a process can be compliant if it meets predetermined specifications, or they can be non-compliant if the output does not meet predetermined specifications. Based on whether or not a process is capable of generating a compliant output, a process can be considered to be in control if the process is capable of generating a compliant output, and out of control if a process is not capable of generating a compliant output. Processes cannot be expected to stay within control over time without any intervention. A process could start off in control, but could get out of control as time passes if it is left alone. The main reason for processes going out of control is the change in quality of an input as time passes. In other words, in many processes, the quality of input deteriorates over time, and this causes the process to get out of control. So how do we maintain the process output at a compliant level at all times, even when the process input change? It can be done in 3 simple steps. Step 1, obtain feedback from the actual output. Step 2, measure the feedback obtained against what is acceptable, that is predetermined specification for output. And step 3, if feedback represents a current or potential variation from specification, make changes to input as needed. That, in a nutshell, is the concept of process control. Process control refers to techniques used to maintain a process within control at all times by using feedback from the output to make necessary adjustment to the process to ensure a process remains capable of generating a compliant output at all times. In the car example, this could be human eyes looking at the changed road conditions or looking at the changed posted speed limits and using previously acquired knowledge to realize current speed is more than the legal limit and manually intervening to apply brake to reduce the speed to legal limits. This is referred to as closed-loop control system, which is different from open-loop control system where the feedback from the output is not necessarily used.
Okay. Here we should say it again. Programmable logic control website how you work in PLC closed loop control. Yes. Okay. Let's see. What do we have? Explain the term of process. Explain concept of process control. Process. A process is a series of steps that take certain input and realize intended output. Okay. A process is a series is a process is a series Y have S. Okay. Series of stuff that say that certain input and generate intended output. That certain input and generate intended output. Okay, maybe SS. Oh, set input generate intended output. Certain input and generate output. Concept of process control. Start with control, budget control. So to simple that to so maintain process input and one level where process control refer to technique used to maintain a process within control at all time by using feedback from the output to make necessary adjustment to the process to ensure our process remain capable of generating a compliant output at all time. Process control refer to technique used to maintain maintain the process within control. Used to maintain a process within control. Maintain a process within control as on time by using feedback from the output as on time by using feedback from the output feedback from the output to make necessary adjustment to the process to make necessary adjustment to the output adjustment to the process to the process to ensure our process maintain capable of generating a compliant output at all time. To ensure our process is capable of generating to ensure our process remain capable of generating a compliant output at all time. To ensure our process remain capable of generating a compliant output at all time. Okay, that's all time. Okay, that's to ensure our remain capable of generating a compliant output at all time. Okay. Closed-loop process control system.
Welcome to lesson 2. In this lesson, we will discuss the need to use programmable logic controllers, or in short, PLCs, and robotics to enable highly responsive and reliable closed-loop process control systems. Such systems are used in fast-paced shop floor that are hallmark of distributed manufacturing enterprise network. As discussed in the previous lesson, closed-loop control system relies on three main things. One, obtaining feedback from process output. 2.
Perform
Performing the necessary
calculation
calculations
to
to
compare
compare
the
the
output
actual output
against
against specification to decide
specification.
if there is a current or a potential deviation of the actual output from intended specification. And 3, if such a current deviation is present, decide
Deviation
on the
using
changes to the input and
input.
execute the changes as planned to maintain process within control. The execution tasks need to operate under the following conditions. They have to be real time. Otherwise, process that is suspected of going out of control cannot be brought back in control in a timely fashion. Rugged environments. Industrial settings typically are represented by severe conditions such as dust, moisture, heat, and cold. Space constraints, limiting the use of excessive hardwire, relays, and timers. And multiple input-output arrangement. A typical process control system has to obtain feedback from several data points and will need to provide output to several devices to actuate planned process changes. The execution task under such conditions necessitates the use of PLCs. In other words, PLCs are one of the solutions to satisfy the above condition and provide the functionality of a closed-loop process control system. Now let us focus on the main components of a PLC system. First, input arrangement. They obtain feedback from process outputs. 2, processors. They perform the necessary calculations to compare the actual output against specification to arrive at changes required to the inputs. 3, output arrangement. They provide signals to external devices such as robotic arms that will be used to execute the changes as planned to maintain process within control. And finally, the power supply, which powers the overall PLC system.
Power supply.
With the basic understanding of different PLC components, we are ready to define PLCs. A programmable logic controller, or PLC, is a robust industrial computer that monitors input and output and makes a logic-based decision for automated process or machines. The output generated from PLCs need to be transformed into actual change in the process to keep the process in control. Sometimes this could mean increasing the speed of a conveyor belt or decreasing the temperature of a furnace for a limited time. This is where industrial robotics play a critical role in the process control. Industrial robots receive the output from PLCs in terms of what changes are required to the process input to keep the process in control and actually executes the required changes in an accurate manner and in a responsive fashion. By responsive, we mean executing the change without much delay. Industrial robots are capable of multiple tasks, such as lifting heavy loads and changing position of devices with a high degree of resolution and accuracy. These robots are primarily automated to perform tasks without human intervention.
Without human intervention. Okay. Nature instrument simple PLC control system from Siemens. PLC component program adaptive control from adaptive control for the next okay. Okay, something. What is the purpose of data processing in logic control? Data processing analyze data. We should call data point to about data processing to okay to data processing will be necessary calculation to compare to output with to perform data processing to create perform the comparison, perform the necessary calculation, the necessary calculation to compare the actual output against specification to compare the actual output, the actual output, again specification, again specification. Okay, it learn how robotic component, how it learn how robotic control, robotic the output where I need to be control actual train, putting in trade speed, capable of multitasking that we can have the report where I need to be control actual train in the website to keep control of time. Robotic robotic have to transform to okay robotic have robotic have the output variety from it the output the output varieties have the output variety from it have to transform have have to transform have to transform the output to have to transform the output into into actual actual chain in the process actual chain in the process to have to change into the process to keep the process in control in control okay a rush computing device that take feedback from the process perform necessary calculation to decide on needed by the processor. Okay, so for this one, data processing. So this is calculate data processing. Data processing, proper data processing. Proper to convert convert raw 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 data to usable data. Okay, raw data to usable data. That's it. Okay. Right again. Data processing performance. Data processing performance necessary calculation to compare First one, compare the actual output and decide if the current or potential deviation of actuator from the intended specification. If check the deviation, if the chain current potential decide on the chain through the input process what where how much what of the required chain receive. Industrial output receive the output from the PLC in term output from this in term what chain required set input keep set in control to and actually execute the required chain in two different manner. They are accurate manner, responsive manner, execute the chain without much delay. Technique by computer from process performance recognition to the sound chain by take programmable control in a computing device. Okay. Programmable logic control. No. Okay. Receive the output from the PLC in terms of what chain are required to set input. People set control and actually execute the required chain into accurate manner, responsive manner. Okay, got that. Now, yeah, I think we finished here. We will start again to adaptive control and manufacturing process control later. Okay, we finished here. Thank you. See you next time.